Hey everyone, welcome to another exciting and science-packed video on Evano. Have you ever wondered why the sun, this massive ball of fire in the sky, never burns out? How is it that it's been producing so much energy for billions of years without exploding or going cold? If you're curious about what's really going on inside our star, stay with me until the end of this video, because today, we're taking a journey into the heart of physics, astronomy, and even the future of the sun itself. Let's clear something up right away. When we hear the word burning, most of us picture flames, like when wood burns or a candle is lit. That's what scientists call chemical combustion, and it needs oxygen to happen. But here's the thing, there's no oxygen in the sun, so how does it burn? The answer lies in one of the most powerful concepts in modern physics, nuclear fusion. The sun is made mostly of hydrogen gas. Deep in its core, pressure and temperature are so intense that hydrogen atoms collide and fuse to form helium. In the process, a small amount of mass is lost and turned into energy, thanks to Einstein's famous equation E = mc2. Even a tiny bit of mass can create a huge amount of energy. Every second, the sun fuses over 600 million tons of hydrogen into helium. Around 4 million tons of that is converted directly into energy. Now that we know the sun is powered by fusion, the next question is, why hasn't it run out of fuel yet? Here's the amazing part, it has an enormous amount of fuel. About 70% of the sun's mass is hydrogen. With this much fuel, scientists estimate that the sun can keep shining for about 10 billion years. And guess what? We're only halfway there. The sun is about 4.6 billion years old, and still has roughly 5 billion years to go. Another great question is, with all that energy and mass, why doesn't the sun just blow apart, or collapse in on itself? The secret is a perfect balance, called hydrostatic equilibrium. On one side, gravity is trying to pull everything inward, trying to collapse the sun. On the other, the energy from nuclear fusion pushes outward, creating pressure. As long as these forces stay balanced, the sun remains stable, and that's what's been happening for billions of years. To understand how special the sun really is, let's look at some mind-blowing numbers. The surface temperature of the sun is around 5,500 degrees Celsius, about 9,940 degrees Fahrenheit. But in its core, the temperature exceeds 15 million degrees Celsius. The sun produces around 384 septillion, 600 sextillion watts of energy every second. And only about 1/2 billionth of that energy reaches Earth, yet that's enough to power life. Unfortunately, or fortunately depending on how you look at it, the sun isn't eternal. According to the latest research from NASA and the European Space Agency, the sun will eventually run out of fuel. In about 5 billion years, when the hydrogen in its core is depleted, the sun will enter its next phase and become a red giant. It'll expand so much that it might even engulf the Earth. After that, it will shed its outer layers and eventually shrink into a white dwarf, a dead, dim star. Absolutely. And it might even save us in the future. Scientists have been working for decades to replicate nuclear fusion here on Earth. Why? Because it's a potential source of clean, limitless energy with almost no pollution. A major experiment called ITER, based in France, is currently trying to achieve controlled nuclear fusion. If it works, it could revolutionize how we power the planet. We can't hear the sun because space is a vacuum, but NASA has recreated its sounds using vibration data. The sun rotates every 25 to 35 days depending on the latitude. It doesn't just affect our light and heat, it also influences our mood, sleep, and mental health. So to sum it all up, the sun doesn't burn, it fuses. Its energy comes from the fusion of hydrogen atoms, not combustion. It will be with us for billions more years, but not forever. If you enjoyed this journey into the heart of the sun, don't forget to like, comment, and subscribe to Evano. We've got a lot more fascinating science content coming your way. Until next time, stay curious, and see you in the next video.